Hello guys, hope you're doing well. And today we are going to do a very basic analysis of a force in which we are going to resolve a force into its respective components in different quadrants. A very basic mistakes made by students while studying statics and mechanics, engineering mechanics. So here we have four quadrants. As you can see, I have shown you on the left hand side. These are the four quadrants: quadrant 1, quadrant 2, quadrant 3, and this is our quadrant 4. Okay, these four quadrants are being shown to you, and we are going to have the force F over here. This is our force F and this is our angle theta, and we will see how the components are being resolved with respect to the quadrants. Okay, so firstly, if you look at it, we will say that if we have in the first quadrant, this is our first quadrant, and if this is our force F, this is our force F, it makes an angle theta. So its components will be, this component is going to be F cos theta, and again it is positive, and the other component, which will be this component, if you look at it, it will be F sine theta. This is going to be F sine theta, and this is our resultant F force. Okay, if the same force which is in the first quadrant makes an angle of theta with the y-axis, okay, it is making an angle theta with the y-axis, and this is the theta. Now what will happen? We were very much interested. If you look now, the components will still be f cos theta sine theta, but its direction will be slightly reversed. If you look at it, this will be our one component, and by head to tail rule, and this will be the other component. So okay, so now you can say the components will be uh, again, you can say this f cos theta is basically, you can say this is the horizontal component, this is the vertical component, but now this component f cos theta is the vertical component and this is the horizontal component. So you will say this component as f sine theta, and this component will be f, sorry, this component will be, sorry, just a mistake. This component will be f cos theta. This component of ours will be f cos theta, f cos theta, and this will be f sine theta. So you will say that your fx is f sine theta and your fy is f cos theta, and in this component over here, this will be your fx will be f cos theta and fy is f sine theta. All right, so we have done with the first quadrant. Okay, now we are basically being interested in the second quadrant. So if you look at it, this is again that same force F, it's make an angle theta with the x-axis. So what will happen here? You can see before, when the first quadrant, all components are positive, only the vertical and horizontal components have changed. Okay, here the horizontal component is f cos theta, here the horizontal component is f sine theta, and vice versa. So now when we resolve it, we will be resolving it like this. You will be getting one component like this according to head to triangular law of vector addition, and the other component will be something like this. Okay, so now we will write this as This is the resultant force F, and again remember this is minus x. So your Fx will be minus F cos theta, and your Fy is going to be F sin theta. And this is how you're going to do it in the second quadrant. And again in the second quadrant, if we have again the second quadrant here, just make it straight. We have the second quadrant here, F, and this F is making an angle theta here with the y-axis. So now what will happen? How are we going to resolve this? Where it is going to be again very easy. We will be using head to tail rule. We can say this will be our component along the y-axis. This is the component along the y-axis, and then this is the component along the x-axis. So now and this is your force F over here shown. So what will be Fx now? Fx now will be, you can easily say it will be minus F sin theta. And what will be Fy? Fy will be positive F cos theta. So these are the top two quadrants we have done. Okay, so again now we go to the third quadrant to see how it is going to be different. Now let's go to this component, this third quadrant. If we have this force here, we have this force, and this force makes an angle theta, and it is making an angle theta with the negative x-axis. And remember, this is again your negative, don't forget, this is your positive. So now we can see the components will be, if we resolve it, the components, it will be one component along this, the horizontal component will be along the negative x-axis, and there will be one component which will be along the positive y-axis. So now what will be the components? How will we write? We will say Fx is equals to minus F cos theta, Fy is equals to minus F sin theta. So all two quadrants are now negative. The Fx is minus F cos theta, and Fy is basically again minus F sin theta. Okay. So now we go the same third quadrant, but we will now resolve it slightly differently. Say this is our force F, and it is making an angle theta with the negative y-axis. So how are we going to proceed now? We are going to proceed again very simple. We will do the triangular law of vector addition. This will be one component, which is this one, and this will be the other component. You can see now what will be our components, and remember, don't forget, this is our force F. So what will be Fx now for this quadrant? Fx now will be minus F sin theta, and Fy will be minus F cos theta. So it is quite clear, we are in the third quadrant. Whichever orientation of the angle is, the components will be resolved in this manner. Okay, so this is now done, and if we want, we can just simplify this and remove this first, and just make it more easy. all of us. This is minus f sine theta. Okay, and let's make it a bit further for ease of our calculation. So let's go to the fourth quadrant, and we say that this is our force F. This is our force F, and this force F is making an angle theta with the positive x-axis. So now how are we going to resolve it? It is very simple. One component will be taken and resolved like this, and the other component using the triangular outer addition will be something like this. Okay, so how will be the components written? Okay, for fx it will be very simple, the same, f cos theta, and for fy it will be minus f sine theta. Okay, and still one job is remaining, and we can say that in the fourth quadrant, this is our force F. Okay, and it is making an angle theta with the negative y-axis. So what will happen now? What will happen is that we will have the components again using triangular outer addition. We will try to resolve it, and we can see very easily that there is going to be one component, there is going to be one component here, and there is going to be another component here. And how are these components going to be written? Okay, they will be written very simply. What will be fx? What will be fx? Fx, if you look at it very closely, it will be nothing but f sine theta. And what will be our fy? Fy will be minus f cos theta. So a very common mistakes made by students. So just to let you know, you must understand this, very important, otherwise you will make mistakes when you're doing equilibrium of particle and moments. So please be very careful when resolving these components. Okay, so I hope this concept will make your concept clear on resolving a force vector in various quadrants. I thank you very much, and you have a wonderful day.